Today we are going to discuss vector addition. In that we'll discuss parallelogram law of vector addition, triangles law of vector addition, polygons law of vector addition, and also we'll take the different cases there for the two vectors which are inclined at different angles there, and what are special cases we are getting and what will be the result there. After that we'll do resolution of vector, and finally we'll do the difference of vectors or vector subtraction. All these it will be discussed in today's discussion. Let's now take addition of vectors. For the addition of vectors we have different laws. One is the parallelogram law of vector addition, another is triangles law of vector addition, and also we have the polygons law of vector addition. So let's do them one by one. So parallelogram law of vector addition says vectors to be added are represented as adjacent sides of a parallelogram. Then the resultant is given by the diagonal of the parallelogram having same initial point as given vectors. So here, suppose I have a vector A. This is vector A. And we have another vector B. We want to find the sum of the two. These two are inclined at an angle theta. This is your vector B. So first of all, we will represent them as adjacent sides of a parallelogram. That means the two vectors should have the same initial point. Now we'll complete the parallelogram. So if you complete the parallelogram, then we get it like this. This is your vector B. As it is a parallelogram, so this side will be parallel to this, having same magnitude as the other one. So this is your vector B. This one will be your vector A. So we complete the parallelogram. Then the diagonal of the parallelogram. Remember, in a parallelogram you have two diagonals. And if you take any particular diagonal, then for that diagonal also, suppose I take this diagonal. For this diagonal also we have two directions. One in this direction, other will be this. If I take this diagonal, again it has two directions there. So in the parallelogram, that way if you take in vector terms, there will be four diagonals. Of course, for the pair of the diagonals, they are equal in magnitude, but directions are opposite. But in terms of the vectors, if you say, there are four diagonals there. Out of these four, only one will represent their resultant. So the diagonal which has the same initial point as the given vector represents the resultant. So this particular diagonal, if I take, starting from the same initial point as the given vector, this one will represent the resultant vector R. So this is the resultant vector. So vector A plus vector B, this is your vector R. Here what we get? Vector A plus vector B, this is your vector R. Now if this is the resultant, in that case, what is the magnitude of this resultant? At what angle it is inclined? Because being a vector quantity, it must have the magnitude and direction. We can try to find out the expression for the magnitude and direction of the resultant vector. So there is a derivation for that. So we'll do that particular derivation. For that, let's assume that this is your point O, this is your A, this is your B, this is C. We drop a perpendicular from point C on OA produced and let it be CD. So now, if you consider this as a right angle triangle OCD, in that case, in triangle CDO, OC square will be equal to OD square plus CD square. And how much is this OC? OC we have represented with the vector R. So that means this is your R square. OD we can write, this we can write as OA plus AD. So this is your OA plus AD whole square. And this is your CD square. Now if you see in this particular triangle, so in triangle CDA, this triangle, if this is angle is theta, that means this angle is also theta. So here CD by AC, this will be equals to sine theta, and that gives CD equals to AC sine theta, or AC is basically your B, so it is your B sine theta. And AD by AC, this will be your cos theta, so AD will be equals to AC cos theta, and that is your B cos theta. So now we can put the value of CD and AD from that in this expression. So if you substitute it, then R square will be, OA is nothing but your A, this is your B cos theta whole square, and this is your B sin theta whole square. So R square is A square 2AB cos theta, B square cos square theta, B square sin square theta. Here you can see R square will be your A square plus 2AB cos theta plus B square, and then this is your cos square theta plus sin square theta. So this is your R square, A square plus 2AB cos theta. This sin square theta plus cos square theta is 1, so it will be simply B square. And now we can write for R, which is the square root of A square plus B square plus 2AB cos theta. So this gives the magnitude of the resultant vector. The resultant R, being a vector quantity, it must have the direction also. So suppose if I take phi as the angle made by the resultant with the vector A. So there in this particular triangle, if you take, what we can write for this? We can take tan phi equals to CD by OD. This is your CD by OA plus AD, and this is your B sin theta by A plus B cos theta. If you just substitute for OA as A and AD as B cos theta, so phi will be equals to tan inverse B sin theta by A plus B cos theta. So this is the expression for the angle made by the resultant with the vector A. Whereas this R, which is your square root of A square plus B square plus 2AB cos theta, this gives the magnitude of the resultant. After parallelogram law of vector addition, the second one is triangle's law of vector addition. In triangle's law of vector addition, the vectors to be added are represented in such a way that the tail of second vector lies at the head of first vector. Then resultant is given by a vector from tail of first to the head of second vector. That means if I have a vector A and I want to add vector B to that, this is vector A and I want to add vector B. So B vector will represent so that its tail is at the head of vector A. This is your vector B at the required angle. If suppose it was at an angle theta, we'll put it at the angle theta. The resultant will be a vector from the tail of first to the head of second. So this is the tail of first to the head of second. So this will give you the resultant vector R. So again here you will get A plus B vector given by vector R. So this is how in triangle's law of vector addition you can get the resultant. You have to only put the second vector in such a way that the tail of the second vector lies at the head of first, and the resultant will be from the tail of first to the head of second vector. If you look at the diagram which we get for parallelogram method, here you have this as the vector A, this was the vector B. They had the initial point at one particular position. In that case, we have completed the parallelogram. Resultant was given by the diagonal of the parallelogram having same initial point as the given vectors. So that means here also we can take as it is a parallelogram, if this is vector B, this is also vector B. So this is our vector B. Okay. Now, this we are discussing how they have got the idea about the triangle's law of vector addition. If you have the vector A and B, you are adding. Now this is your vector A. Here you have the vector B. Resultant was R. So that means in this particular part, I have all the three, vector A, vector B and R. So we don't need the entire parallelogram. This is your vector A, this is your vector B, this is your resultant. How the vector B is oriented now? Here in the parallelogram law, the two had the initial point at one particular position. But here in this triangle's law, we have put the vector B such that the tail of B is at the head of vector A. And now the resultant is here from the tail of first to the head of second. So this is how your triangle's law, this is how in triangle's law you can get the resultant vector. And now if you have to get the magnitude and direction of the resultant, what we can do? We can simply drop the perpendicular from point C. We can produce OA and let the perpendicular drop be CD on the OA produced. Again, you have the same triangle CDO, and the same way you have OC square equals to OD square plus CD square. So exactly same derivation will be here also to get the magnitude of the resultant. We can get the angle made by the resultant also in the same exact manner as we have done previously, and you have tan phi equals to CD by OD, giving you ultimately phi equals to tan inverse B sin theta by A plus B cos theta. So in triangle's law, basically we just change the arrangement of the vectors to be represented there, and you can get the resultant. For the addition of two vectors, we have got the expression for the magnitude of the resultant vector as the square root of A square plus B square plus 2AB cos theta, and phi, which was the angle made by the resultant with the vector A, as tan inverse B sin theta by A plus B cos theta. If you now take different cases here, that means we take the different values of theta there, then what result we get, what magnitude value we get, what angle we get for the resultant there. So let's take these cases. Suppose we take the case 1 when theta is 0. When theta is 0, that simply means the two vectors are in the same direction. So for that case, if you consider R, it is A square plus B square plus 2AB cos 0 square root, which is your A square plus B square plus 2AB. Because cos 0 will be 1, so this is your 2AB only, and this is your A plus B whole square root. This is your A plus B. So what does it indicate? That the magnitude of the resultant will be equal to sum of the magnitude of the individual vectors if the two vectors are in the same direction. That is, theta is 0 here. Let's take what is the angle made by the resultant with the vector A or any of the vector, because the two vectors are in the same direction. Whatever angle it will make with A, it will be the same angle with the vector B also. So phi will be equals to tan inverse B sin 0 by A plus B cos 0. And since sin 0 will be equal to 0, so in that case it will be ultimately 0. So the angle made will be 0. That means the resultant will also be in the same direction as the given vectors. Now in the second case, when theta is pi, that means the two vectors are in opposite direction. So then R will be root over A square plus B square plus 2AB cos pi. Cos pi is minus 1. So it is the square root of A square plus B square minus 2AB. and that will be square root of A difference B whole square. That we can write it as A difference B. We are taking difference. We are not just taking A minus B, because this R represents the magnitude of the resultant. If suppose we take it as A minus B, chances are there that there may be confusion for the case. If suppose A is given that A is 3 Newton, it is a force, suppose 3 Newton, and B is 4 Newton. They are acting in opposite direction. So if I just substitute in the formula for the magnitude of the resultant, what I will get? It will be A minus B, if we have written that. So it is 3 minus 4, and what we will write? Minus 1. But what is this R? R is the magnitude. Magnitude cannot be negative. So just to get rid of such type of confusion, it is better if you use A difference B. Whichever is the bigger one, from there we'll subtract the other one. So that is why we are using A difference B. So if it is your 3 and 4, so whether you take difference of 3 and 4, it is 1, or it is your 4 and 3, that is also 1. Then phi, which is the angle made by the resultant with the vector A. So again it is your tan inverse B sin pi divided by A plus B cos pi, which is 0. Let's take case 3, when theta is pi by 2. So if this is the case, then R will be a square root of A square plus B square plus 2AB cos pi by 2, and cos 90 is 0. So in that case, it is a square root of A square plus B square. And phi, if you take, this will be your tan inverse B sin pi by 2 by A plus B cos pi by 2. This is equals to your tan inverse B by A. Because sin 90 will be 1 and cos 90 will be 0. So it will be tan inverse B by A. So that will give you the expression for the angle made by the resultant with the vector A. In Polygon's law of vector addition, the vectors to be added are represented in cyclic order. That is, the tail of the second vector being at the head of the first, then tail of third at the head of the second, and so on. The resultant will be given by the closing side of the polygon taken in reverse direction. Let's see what does it mean. Like suppose you have the vector A. This is vector A. And if you have to add vector B to this, so vector B will represent in such a way that the tail of B is at the head of first vector A. So this is your vector B. Its tail is at the head of vector A. Then you have the vector C. We put vector C so that its tail is at the head of vector B. You have another vector, suppose D. This is the vector D. Its tail is at the head of the third vector C. Now the resultant will be given by the closing side of the polygon. If I just close this one, in that case this will make a closed polygon there. So this is the closing side of the polygon. That means you have to just connect the end point of the last vector and the starting point of the first vector. And this is the closing side of the polygon. But you have to take the vector in reverse order. That means if we are moving in this way, that means we are moving, say, in the anti-clockwise direction. So usual way of representation would have been like this. Resultant is now taken in reverse direction. So this will be your vector R, because now it is in reverse direction. This will be basically from the tail of first vector to the head of the last vector. So that will represent your resultant vector. So this vector R is basically vector A plus vector B plus vector C plus vector D. This is your vector R. So this is how in Polygon's method we add vectors. You have to only represent the vectors in cyclic order, and then the closing side of the polygon will represent the resultant vector. Now let's see how we get this one. If this is your vector A, this is your vector B, the tail of B is at the head of A. So now the resultant of these two will be given by a vector from the tail of first to the head of second by triangle's law vector addition. So this will represent your vector A plus vector B. So this is your vector A plus B, which is the sum of vector A and vector B there. Now this is your vector A plus B. This is your vector C. Tail of C is at the head of A plus B. So that means this one will represent vector A plus B plus C. Now this is your vector A plus B plus C. This is vector D. So obviously this R will represent your vector A plus vector B plus vector C plus vector D. So this is how you can show that the closing side of the polygon taken in reverse direction gives the resultant vector. There can be another way in which you can prove this one. This is your vector A, this is your vector B, this is suppose your vector C, this is your D. Okay, this is the closing side of the polygon. I am taking in the normal way. That means this I am taking as R dash. That means this is not in the reversed order. This is in the same order in which we have added the vectors. Now if you see that, what you will get? You will get it as a closed figure and the vector returning to the same point. So here, if you now consider vector A plus vector B plus vector C plus vector D plus vector R dash, this will be 0 because we have come back to the same point from where we have started. So here, how this R dash was the closing side of the polygon but taken in same direction. If I take the vector R, which is in reverse direction, so that means R vector will be equals to minus R dash vector. Okay, because the two are in the same, they are of same magnitude but in opposite direction. So basically R dash is the negative vector of R. So here, if you just consider A plus B plus C plus D, and R dash is taken on right side, and since R dash is now equal to R, so we can simply write it as R. So we can prove that it is the closing side of the polygon taken in reverse direction that gives the resultant of the vectors. So far we have discussed addition of vectors. Now what does the addition of vectors physically mean? Addition of vector physically mean that if you have a number of vectors acting, then the resultant is a single vector which can give the same impact as produced by all the vectors in combined way or all the vectors together. So this is just like replacing a number of vectors acting together by a single vector. Resolution of a vector, if you consider, it is just like splitting a vector into its component, into different vectors there. So it is just like, you can say, reverse way of addition. In addition, you are adding vectors to represent a single vector, which can give the same impact or which produces same impact there. Resolution will be splitting up of a vector into different components or vectors there, which has same impact as the single vector there, just like the reverse process. So how we do that? Suppose here you have one vector. This is vector A. I want to resolve it into two components which are mutually perpendicular. Suppose I want to resolve it into a vector along x-axis and another is there which is along y-axis. Suppose this vector is at an angle theta with the x-axis. So this is suppose point A and this is your A. So if I drop a perpendicular from this, then this is suppose your M. On X axis it is your OM, on Y axis it is suppose ON. This is basically the component of the vector along X axis. So OM is component of vector along X axis. And how much it will be? You can see that OM by OA, this will be your cos theta, that is OM will be your OA cos theta. So it can be written as your A cos theta. This is your ON by OA, ON by OA. This ratio we can also write ON as AM. So it is your AM divided by OA, that is your sin theta. And this, if you take, then ON will be how much? OA sin theta. This is equals to A sin theta. So what we can say? A cos theta is its X component, A sin theta is its Y component. So if it is this as the component, A cos theta, A sin theta, the vector along X axis, if I represent, we have the unit vector I along X axis, unit vector Y, J along Y axis. So what we can write? Vector A1, or suppose AX if I write, it is your A cos theta I cap. Vector along Y axis, this is your A sin theta J cap. So that means the vector A can be written as A cos theta I cap, A sin theta J cap, which is basically AX vector, AY vector. So what you could see, the vector A is now resolved into two vectors, AX and AY. What is this AX? AX is the vector along X axis, AY is the vector along Y axis. So you have got the component of the vectors as A cos theta and A sin theta. So this is the resolution of the vector there. Now, of course, let's see that whether the vectors which we have resolved into the two components, they are the correct one or not. So how will you check? We can check if the sum of the two vectors gives back your vector A. Then you can say that this resolution is correct. So let's take now magnitude of vector AX plus AY. Remember, AX vector and AY vector, they are in mutually perpendicular directions. So if the two vectors are mutually perpendicular, how we get their resultant? It is simply AX square plus AY square. Angle between the two is 90. So in that case, cos 90 term will be there. That will be giving you the 0 value. And this is how much? A cos theta. We have just derived this value of A cos theta as AX. So this is your A cos theta whole square. This is A sin theta whole square, square root. We are just putting the value of AX and AY. This was your X component of the vector. This is basically your AX. This is your AY. So here you have a square root of A square cos square theta plus sin square theta. Cos square theta plus sin square theta is 1. So this is your A only. So we can show that this resolution is a correct one, because if the resolution is correct, it means adding the two together must give the original vector. So we have got the original vector A. So this is how you can resolve. So whenever you have to resolve a vector into two mutually perpendicular, three mutually perpendicular direction, if suppose z-axis is also there, in that case we can resolve along that direction also. Then the direction with which it is making angle theta, you just remember with that it will make a cosine ratio. So this is your A cos theta, and the perpendicular direction it will be sine theta. In physics, where we'll get that, or where we'll be using that? Suppose you have an inclined plane, and on that we have a body of mass m. This is the body of mass m. So its weight will be acting downward, mg. Now this body will be sliding along the inclined plane because there will be one component of this weight along down the inclined plane or along the inclined plane there. So here, if I resolve this one, in that case, if I resolve this mg in two mutually perpendicular direction, so along this, now it is your mg sine theta, and in this direction it will be your mg cos theta. Normal reaction will also act there, normal to the inclined plane. So this is your normal reaction R. So here you can see that R will be equals to mg cos theta. So you can get the equilibrium of the body in the perpendicular direction to inclined plane. Whereas mg sine theta will be the component of the weight down the inclined plane. If this is the frictionless surface, the body will move with this force. If friction is there, in that case, there will be a force of friction acting in opposite direction there. So if force of friction is there, in that case, it will act in this direction. So resultant will be mg sine theta minus f. It will be giving you the component in the different directions. So with that, you can easily get the equilibrium, or you can get the equation there for getting the free body diagram and writing its motion equations, or for writing the equations for its motion. Another example is that suppose you have a body of mass m attached with a string, and there are two other strings also which is connected as shown here. The tension developed in the strings is T1 and T2. This angle is suppose your theta 1 here, this is your theta 2. So if it is such, for its equilibrium we can resolve, like tension will be resolved here in this direction as T2 sine theta 2. In this direction it will be your T2 cos theta 2. For T1, if you represent, it will be your T1 cos theta 1, and here it will be your T1 sine theta 1. So in this direction what will happen? T1 cos theta 1 plus T2 cos theta 2. This is equals to the weight. If it is an equilibrium there, so it is your mg. Whereas for equilibrium in the perpendicular direction there, so that is in the horizontal direction, if you consider, it is your T1 sine theta 1 equals to T2 sine theta 2. So with that you can get the equations for its equilibrium. Let's take vector subtraction or difference of vectors. Suppose we have two vectors A and B, and we want to take their difference. So this A minus B we can write as vector A plus minus vector B, and this is minus vector B, we can call it as the negative vector. It means vector subtraction, we can take it as the sum of first vector and negative of second vector. That will give the vector difference of the two given vectors there. That we don't have any different law there or expression there for difference of vectors. We can simply apply the concept of addition of vectors. Only thing what we have to take care that it has to be the sum of first vector and negative of second vector. So suppose we represented it like this. Suppose this is your vector A and this is your vector B. This is vector A, this is vector B, and it is inclined at an angle theta. So for getting the difference, what we'll do, we'll represent this vector B in opposite direction. So we'll represent it in opposite direction, and its magnitude should be same as the given vector B, so that we can get the negative vector So here this is your minus vector b. And now the difference of this will be given by the sum of first vector a and negative vector b. So we'll complete the parallelogram for that. And the diagonal of this parallelogram having the same initial point as the given vectors. Now this one will represent your vector a minus b. And if you want to get the expression for the magnitude of this one and at what angle this vector is inclined with the first vector there, then we can simply use the expression for the resultant for the addition of vectors. So suppose if we consider that angle between vector a and b is theta, then angle between vector a and minus vector b, this will be 180 plus theta. Because if angle theta we have measured in anti-clockwise direction, then the other angles should also be measured in the same direction. So here, if you consider now the magnitude of a minus b vector, then this will be given by the square root of a square plus b square plus 2ab cos 180 plus theta, which is the angle between vector a and minus vector b. So this will be the expression. And now if you take this one, this is your a square plus b square. Cos 180 plus theta is minus cos theta. So this will be equals to minus 2ab cos theta. So this is the magnitude of a minus b. So we have got the magnitude of the difference of the two vectors. If you want to find out at what angle it is inclined, so for that again, if you consider this is the vector a and this is the resultant there, that is a minus b, and if I assume this angle is phi, phi is the angle made by a minus b vector with the vector a. So for that case, for that we can write tan phi equals to b sine angle, that is your 180 plus theta, divided by a plus b cos 180 plus theta. And this is equals to sine 180 plus theta is minus sine theta, so it is your minus b sine theta, and this is your a, and again cos 180 plus theta is your minus cos theta, so it is your minus b cos theta. We can just get rid of this negative if you just change the order here of the terms in the denominator. So we can write this one as your b sine theta divided by b cos theta minus a. We have simply changed the order of this term in the denominator so that we can get rid of this negative sign. And now phi we can write as tan inverse b sine theta by b cos theta minus a. This is the expression for the angle made by the resultant, that is vector a minus b with the vector a, and the magnitude is given by this formula, that is the square root of a square plus b square minus 2ab cos theta. So this is how we can get the magnitude and direction in case of the difference of two vectors.